This session we discuss about the curl of a vector field. So start by defining what we mean by the curl, and then do one or two examples to illustrate how to compute curl. So let V be a differentiable vector field. So I have our V being a differentiable vector field. Then the curl or rotation of V denoted by or rot V, or given by is defined as curl of V equals this determinant So this is how we define curl of the vector field V. And then we can further reduce this third determinant into the form. So deleting the expanding along the first row, and always remember this has plus sign, minus, plus. So remember this is K. This one has plus sign. Remember this determinant work on from algebra. So expanding along the first row, close this and close this will have partial y, partial z, v2, v3 times I minus the subdeterminant. So delete this column for j, delete this column for j, and delete this row for j. So we'll have partial x, partial z, v1, v3 times j vector plus. Now for k, delete the row for k, column for k. We'll have the subdeterminant, partial x, partial y, v1, v2 multiplied by k vector. Now these 2 by 2 subdeterminants are evaluated by, so partial y of v3 minus partial z of v2, which gives partial v3 partial y minus partial v2 partial z times I minus partial x, partial v3 partial x minus partial v1 partial z multiplied by j plus partial v2, so this partial x minus partial v1 partial y k. So which you can rearrange as, so this is the curl of v partial v3 partial y minus partial v2 partial z I, and then if I multiply every term by negative sign, so I'll have plus. So this one will be positive, partial v1 partial z, and then minus partial v3 partial x, then j, and then next will be plus partial v2 partial x minus partial v1 partial y times k vector. So that's how we define the curl of vector field or a vector v. So what you have to remember in this definition is that curl of a vector field is also a vector field or a vector quantity. So curl is a vector, or curl defines a vector quantity. So to define curl, you need a vector, and also the end product or the end value will also be a vector. So as an example, given that one find so I have this vector v, and then the question is to define the curl of this same vector v. So solution, by definition, we have curl of v, which can be written in this form. If the determinant I, j, k, partial x, partial y, partial z, v1, v2, v3. In our case, this is our v1. Actually, I can say where in this case, our v1 will be x squared yz. Our v2 will be given by minus 2xy, and v3 will be yz. So I'll have curl of v is this determinant. So partial x, partial y, partial z, and then we have x squared yz minus 2xy, and then yz. Then this will be given by the subdeterminant, delete I row, I column. So I'll have this partial y minus 2xy, partial z, yz, and then I multiply by vector I minus, remember I'm expanding along the first row. So delete this column for j, column for row for j. So I'll remain with partial x squared yz, partial z, yz, and then I multiply by vector j plus, so delete column for k and row for k. I'll have partial x, partial y, x squared yz, and then minus 2xy. Multiplied by vector k. So the next step will be simply partial y of yz, partial y of yz minus partial z of minus 2xy, and then this will give us component of I vector minus partial x of yz minus partial z x squared yz. So that will be the component of j plus, next this subdeterminant is partial x minus 2xy minus partial y into x squared yz. This will be the component of k vector. So this is next step. Now partial y of yz is z. This other part will be 0 because there's no z. So just will have zi minus partial x of yz is 0 minus partial z of this will give us x squared y j plus partial x of this term is negative 2y minus partial y of this is x squared z. Then k. So therefore the final answer will be curl of v equals to z I minus is plus x squared yj, and then we can factor out negative and have negative 2y plus x squared z k. So that is the solution for that given problem. And then next example is also an application of the curl, but then before we do it, then let's make some definition here on what we mean by a rotational vector. So let v given by v1i plus v2j plus v3k be a vector field that you can specify a differentiable vector field. So if curl of v is 0 vector, then V is called rotational. So when the curl of a vector is 0, then that vector is called an irrotational vector. Or if it's a vector field, then the vector field is called rotational. Now, so this calls for the second example, number 2. Determine that or show that the vector field given by V equals to y e raised power xy I plus x e raised power xy j plus 0k is rotational. Now, solution to this dictates that we need to define the curl of the vector v and successfully show that its value is 0. If that is the case, then it will be proving that the given vector field is rotational. So solution or proof, we need to show that curl of v is a 0 vector. If that's the case, then that claim will be true. Then by definition, curl of v is given by the determinant I, j, k, partial x, partial y, partial z, v1, v2, v3. In our case, v1 is y e raised power xy, v2 is the same as x e raised power xy, and v3 is 0. So which means we'll have curl of v will be given by the determinant ijk partial x, partial y, partial z, and then y e raised power xy, x e raised power xy, and then 0. So now the next thing is just to define the determinant of this matrix. So this will be, I am not expanding the determinant along the first row. So this has positive sign, this has negative, this has positive. So delete row for I, column for I. I'll have partial y, partial z, and then x e x y 0, I minus. So j row, j column deleted. We have partial x, and then partial z, and then y e raised power xy 0, j plus delete column for k, row for k, partial x, partial y e raised power xy, x e raised power xy, then multiplied by vector k. So this implies we'll have partial y of 0 minus partial z of x e raised to power xy. So this is the component of I vector minus partial x of 0 minus partial z of y e raised to power xy, that's the component of j, plus partial x of x e raised to power xy minus partial y of y e raised to power xy. This is the component for k. So next step, clearly partial y of 0 is 0 minus partial z of x e raised to power xy, because there is no z variable here. So all this is taken to be a constant, so this would be 0. I minus partial x of 0 is 0. Partial z of y e raised to power xy is 0. And then now, for this other part, partial x of this function here, we'll use product rule. So x e raised to power xy. So this is our u, this is our v. So u prime is 1 because partial x of x is 1 multiplied by e raised to power xy will be e raised to power xy, plus when you differentiate e raised to power xy with respect to x by chain rule, you will get y e raised to power xy multiplied by x. So this is x e raised to power xy plus xy e raised to power xy. So this will be the first value here, e raised to power xy plus xy e raised to power xy minus, now partial y of this function, we are also going to use product rule. So which will be y e raised to power xy. This is u, this is v. U prime is 1 times v e raised to power xy. V prime, remember we are differentiating with respect to y, so it will be now x e raised to power xy by chain rule. Then you multiply by y, you get xy e raised to power xy. And because we are subtracting, so every term here will have a negative sign, e raised to power xy minus xy e raised to power xy, and then k. So once we have that, we do some further simplification. In this bracket, this term and this term cancels out. In the same bracket, this term cancels out, so this will be 0. Also here is 0, also here is 0. So this is the same as 0i plus 0j, whether you say plus 0j or minus 0j, the same thing. And then plus 0k, which is indeed a 0 vector. So since the curl of v turns out to be a 0 vector, then vector v must be rotational. So since curl of v is a 0 vector, then v must be rotational. And that is really what you wanted to prove. Thank you.